Welcome back to the last session of Module 1. Here we will see some measurement systems like anemometers, thermocouple, biosensors and gas analyzers. Okay. Now the first instrument which we are going to deal with is hygrometer, used to measure the humidity of air. Hygrometers are built using human hair, which is sensitive to water content. So the transducer of hygrometer is basically human hair, as shown in blue color in the figure. It is tied with two parallel plates. One side is spring loaded and other side is placed on a rigid surface. The spring loaded section is again connected to a cam shaft mechanism through a connecting link as shown in the figure. So when human hair expands or contracts depending upon the humidity, it passes through this cam and a set of gear. Finally, that movement is transferred to the pointer of the dial. We place a cam for linearizing. The transducer will not give a linear characteristics, it's evident. Only very few transducers can give linear characteristics. One such example is potentiometer. So here you can't expect linear characteristics. So we need cam for linearizing the characteristics of hygrometers. Now we will deal with fine wire thermocouple. You might have learned Seebeck effect and Peltier effect in your plus 2 classes. So thermocouple is an instrument which works on the same principles. When two dissimilar metals are joined at both ends, and whenever there is a temperature difference between the two junctions, say T1 and T2 at hot junction and cold junction, it will produce an EMF proportional to the temperature difference. Again, also this process is very non-linear. So you can't expect linear characteristics. We need to construct a lookup table to get a relation between temperature difference and EMF. The EMF produced is proportional to the difference in temperature, that is T1 minus T2, or voltage is equal to a function of T1 minus T2. This is a property of contact only. The length has no role in the amount of EMF produced. So naturally, there is an advantage of using thermocouples in signal transmission. One part of the length of the wire can be taken into longer distances without signal loss. That is an advantage of thermocouple, which we can employ in agricultural fields also. Now the voltage can be read out by a digital multimeter and displayed as temperature. We will see more details in this thermocouples in industrial instrumentation and other related papers which you will subsequently learn. Now the next sensor which we are going to discuss is biosensors. The working of the sensor is rather little tricky because there is a biological recognition layer in the transducer which is sensitive to the analyte, which contains the specific antigens or special proteins from the biological strains. Now this biological layer is fabricated using polymers and enzyme proteins which is sensitive to particular antigens. So whenever there is a collection of antigens gets sticks or bounds into this biological recognition layer, it will produce a charge change which is marked as E minus, and that charge change is detected by the electrical transducer which is placed inside the cartridge. Okay. Now the problem with this kind of sensing method is that the cartridge cannot be reused again in most cases. It is single use type. And as you are aware of the COVID-19 detection, they perform the initial test, antigen test, by this kind of methods. Okay, so that completes our part in biosensors. Now we will discuss the working principle of sonic anemometer, which is very helpful for farmer in estimating the wind velocity and direction. As some crops like plantain are sensitive to winds, also rice, paddy and wheat, the growth is very sensitive to wind. So this instrument measures the speed of the wind as well as the direction. There is two transmitters and two receivers placed in perpendicular to each other. Both transmit at different frequencies and received at the receiver. Here the time of flight is fixed, but this will rather measure the Doppler shift. So according to the Doppler shift in two axes, x and y, is measured, and this can give a wind profile in a plane or a two-dimensional plane. You can give the wind direction and wind profiles. Very simple instrument. Now the last sensor to be discussed in this video lecture is gas analyzers. The gas to be analyzed is passed through a chamber which is transparent in nature, and IR source is allowed to pass through this transparent chamber. While passing, it is subjected to flashing by the help of a rotating chopper. This rotating chopper will convert the light beam or the IR beam into beam of pulses. This is nothing but just introduce a carrier into the system, and that is detected using IR detector located at the other end. This rotating chopper is driven by a motor, and IR detector, the output from the IR detector is given to a frequency to voltage converter, which can again convert the frequency values into voltage, and it is given to the display systems. Okay, so this detector is a phase sensitive detector, typically that employed in FM receiver circuit. I have not given the circuit details in the figure, which I will give to you later in some sessions. So with this we come to an end to the module 1 series of video lectures. The reference for this session is Ernest Out Doblin, Principles of Measurement System Design and Analysis. So see you on another occasion. Thank you.